Welcome back, and in this new video I will implement with you the last requirement of our project. I just recap what we did before. So we created a calc class with 4 methods, one for addition, subtraction, multiplication and division. And we did this creating many tests with pytest. If you run pytest-svv, you should have this output at this point. Going back to the project, the requirements that we haven't implemented yet, the requirement we haven't implemented yet is the class will also provide a function to compute the average of an iterable. This function gets 2 optional upper and lower thresholds to remove outliers. Okay, so this requirement is a bit more complex than it looks like at the first glance, but it's worth creating the first test and then see if we spot some missing feature in the code that we will write. So the first thing is to go here to the test calc and to write a test. So the requirement wants us to create a function to compute the average of an iterable. So we can define test, in this case average. Okay, so no, sorry, this is not a method. So what shall I do? Assert, as we did before. I have to name this function for consistency. I would say avg, and then we have to pass something to this function. The requirements name an iterable. So one possible iterable is a list. There are many iterables. A tuple is an iterable, a string is an iterable, a range object is an iterable. Actually, you can make your own objects iterables in Python. But in this case, we'll stick with a list. And I fill it with some random numbers. But obviously these are not really random. I prepared them, but yes, some numbers to test. And we assert that the average of these numbers is 29.25, which is the mathematical average of these numbers. So if I go to my terminal and run pytest svv, I expect a failure, which is what I get. Calc object has no attribute average. We know it. We had this error so many times. So we can go here and def avg self of an iterable, whatever, and pass. This is our first move. And the test obviously fails again. Okay, so I go back to my avg function and I implement the correct average. In this case, it's just a sum of a. Actually, a is not a very good name for an iterable. It is better, I believe. So yes, this is the mathematical definition of average, the sum of all the elements in the iterable and the length of it. So let's see if the test passes. Yes, okay, fine. Okay, so this is our solution for the requirement. I foresee some issues, but I prefer to go on with the requirements, implement the missing ones, and then discuss the issues we left in the code. Please remember, this is a workshop, so you are supposed to, well, first of all, follow it with your own code, but a very good way to follow it is to stop the video after we wrote a test and to try to implement the code by yourself, and then comparing your solution with mine. My solution is not always the best one. As I said many times, we are here not to check if we know Python in details, but if we can learn TDD. So go on, stop the video whenever I write a test, and then write your code. If you want, you can also write your own test and then compare with mine. So the missing requirements is this function gets to optional upper and lower thresholds to remove outliers. And what are these thresholds? The idea is that I want to compute the average of this iterable, but only of the numbers in it that are greater than a certain threshold or less than. So let's say, for example, that I want to test the average removes upper outliers. These values over a threshold or under a threshold are called outliers in data science, in mathematics. So what I do is assert that calc.average of the very same iterable, so 2, 5, with an upper threshold. So upper threshold, UT, it's a good name, I believe, 90. So what I want here is the average of 2, 5, and 12. So basically the same thing that would happen if I wrote this, right? So the function should remove this 98 and then compute the average. And the average of these three numbers, 2, 5, 12, is 6.333. So what we want to do is to approximate the result, because otherwise the test might fail, because the precision of the computer we are running our test on is not sufficient or is different. So what we want to do is to run pytest.approx 6.3. For example, this is a way to say, okay, I accept a value which is, for example, 6.33334, which might be the outcome of the calculation. This is my test. I'm going to run it, and yes, and get into an error, obviously, because AVG doesn't provide any keyword argument UT. So going back to our calc file, we have to add the keyword argument here in AVG. And the way to do it is very simple. So we go here, we say UT. This is an optional argument, so we have to give it a default. Actually, if we didn't give it a default, this test would fail. So we have a safeguard for this thing. UT none. And what happens if the upper threshold is not none? The thing is, I have to, well, first of all, you have to stop the video here and go on with your solution. In the meanwhile, I will think about my solution. And I believe the best way to do it is to filter the iterable into a new list and then compute the average of that new list. So what I can do is to say if not ut equal max of iterable. So this way I always have an upper threshold and I don't have to consider the case in which it's not there. So basically the idea is I create my own upper threshold, which is the maximum of the iterable. This way I can always filter the iterable, keeping all the values that are less than the threshold, because if there is no threshold, the upper threshold is the maximum. So all the numbers are less than that number. Less than or equal, actually. So underscore IT, which is my new iterable, my new list, is a list comprehension x for x in IT if x is less than or equal of ut, then ut. And then obviously this becomes underscore IT. Okay, so this is my solution. A couple of things before we check the test is I decided to go for the less than or equal. If you go for the less than, this trick here doesn't work anymore. So you somehow have to come up with something different. You're free to try it. So far, for the time being, I want to stick with this, which is makes everything simpler. Okay, let's go back to the terminal and see what happens. Okay, fine, it passes. I'm happy. My code is okay. It passes the test. So the requirement mentions lower threshold as well. So I want to implement a test for that as well. I can copy it and modify, copy the previous one and modify it. So lower outliers. This time I want to give it a lower threshold of 10 so that these two get removed and we have the average of 12 and 98, which is 55. Cool, this is my test, and if I go here and run it, I get the usual error because the keyword LT is not specified in the class. So, well, first of all, LT equal none. This is the same solution we had before. Code is a bit different now because I have to filter the lower values as well. So if not LT equal minimum of IT, this is the same trick. So now whatever the value of this LT, if there is a value, I keep it. Otherwise, if it's none, I just use the minimum. And here I can add an and x is greater or equal than LT. Yeah, this should be enough. Let's see if the test is happy about it. Yes, perfect. In theory, this is it. But as I said before in the previous videos, tests should check for corner cases. And we haven't checked for any corner case. This is the most important part of testing. Not always you can come up with all the corner cases when you first write your tests. Sometimes someone discovers a corner case, some user or a colleague of yours or yourself. Someone comes back later and comes back to you saying, this doesn't work. So that shows probably a corner case of your code, because when you first created your code, everything was working, but then someone tries a fancy number, someone tries, something that you didn't forecast, and this is a corner case. We should try as much as possible to foresee these corner cases. And this is what I'm gonna do now. So as you remember, I told you before, I went for an equal here and here, so to include the threshold. But there is nothing in my code that checks for that equal to be there. So I want to expose this corner case in a test, and the thing I can do is to duplicate this one and say test average removes upper outliers equality. It's a good way to identify it. And what happened before? So what happens is the threshold is 90, so whatever is less than or equal to 90 gets kept. So the threshold is here somewhere, and 2, 5, and 12 are kept. So what I want to check is that if my threshold is 12, 12 is kept. So 98 is definitely ruled out, but 12 is kept, and we again have the average of 2, 5, and 12, which is approximately 6.33. I expect this test to succeed. And this is what happens. Remember, the test succeeds, so you have to ask yourself, why does it succeed? Do I want to keep it? Yes. In this case, I want to keep it because this, yes, it tests the same thing we have here, but it's a corner case. So here we have 90, which is a random number inside, among these numbers, just to rule out some. Here we have a number which is one of the numbers in the iterable, so we want to keep it. But it's very important for you to ask yourself this question again and again, every time a test succeeds. And yeah, this is the same thing for the lower threshold. So what I did before was to rule out 2 and 5 through these thresholds. Now I want to again give it the lower threshold 12, so 12 and 98 should be included in the calculation, and this should again give 55. Yes, it passes. Again, same thing. Why does it pass? Because this tests something we were already testing, but this exposes a specific requirement. It's not a requirement, sorry. It's a specific choice in my code, which is this equal here and this one here. Okay, another corner case is when the list, when the iterable is an empty one. So what if this iterable doesn't contain anything? So we have to write a test that covers the case and also decide what to do with the iterable, because if the iterable is empty, we have to compute the average and we have to decide what our function will return. So the test is def test avg manages empty list empty iterables. And the code is assertcalc.avg of an empty list, in this case, is something. So, okay, again, as I told you, this should have been designed before, so there should be a requirements design phase after you discuss with your client and you say just, okay, we need an average. In this case, we didn't have time. This is a very basic workshop, so I didn't want to bore you to death. We have to decide, however, what to do with an empty iterable, and we might say, for example, the average is 0. This is perfectly fine, not very mathematically correct. You might want to go with something like this, with pytest raises value error. It's up to you. Let's say what happens with the with this version, and then we might go and change it. So this should fail, and it fails for a specific reason, because max that I use to create the upper threshold when it's not specified cannot be run on an empty sequence. This shows us that probably the most Pythonic way to go for is to raise a value error. But bear with me, let's see what we can do, and then we can change maybe the code later to be a bit more Pythonic. So the solution is very simple, because it's just a matter of saying here, if not len of it, just return 0. Okay, let's see if it works, and it does. And as I said before, the solution I went for is not the best one. I'm not really satisfied by this return 0. It's mathematically incorrect. It's not very Pythonic. So I might prefer to go with this raises value error. This happens many times, especially in the first phases, the first steps in development. If you didn't have a proper design phase, sometimes your requirements change abruptly. Well, actually requirements always change. In this case, they change because we didn't decide a proper API, we didn't discuss it. So I want to go for a proper assertion with pytest raises value error, and I want to run calc average of an empty iterable. Yes, let's see what happens. We get the nice did not raise value error. And if we go back, the solution is very simple, because instead of returning 0, we can just raise value error. And this passes the test. Okay, another corner case is that the list might be empty after we remove the outliers. So basically the function goes there, removes all the values that are greater than the upper threshold and lower than less than the lower threshold, and the list at this point is empty. What happens in this case? So I want to write a test for it. Test avg manages empty list, empty iterable again. After outlier removal. Yes, good. Test name. And what I want to do is to assert that calc.average of an iterable like 1298 with a lower threshold of 15, so 12 is deleted, is ruled out, and ut equal 90, for example. Well, 80, yes, it's fine. Perfect. So, okay, this is something. Okay, I'm sorry, I changed the API is the average of an empty iterable is not returning 0 anymore. So what I want to do is again this. Okay, I guess this is fine. So we are calculating the average of this iterable, but we removed everything under 15, so 12, and I have everything above 80, so 98, and the iterable at this point is empty, and this should raise a value error. Let's see what happens. Cool. It fails with a 0 division error, because at this point in the code of AVG, this gives an empty list, so IT is empty, sum of IT is 0, and the len of IT is 0, so we have a division by 0. And what we can do is, I'm not sure if this is the best code again that I'm writing, but I'm aiming. I want to pass all the tests. This is my target. When my code passes the tests, we can discuss about the best way to write it, and maybe there is something better that you can come up with. In this case, I can just say if not len of underscore IT will raise value error. So this is a repetition of this on a different iterable, and the test suite is happy about it. So for me, this is okay. But we are not finished yet, because there is another corner case, which is that I try to remove outliers from an empty list. So here, I just try to compute the average of an empty list without outliers. I want to see what happens if I pass outliers for an empty list. So this is what I'm gonna do. Test average manages empty iterables with thresholds. So good name. So yes, calc average empty list, and then lower threshold 15 and ut equal 90, 80 that we did before, whatever. The list is empty. Please notice that I keep testing a list, but we are talking about iterables here, so we should insert a test to be sure that we are managing specific iterables in a generic way, not specifically lists. But for the time being, let's keep using a list here, and yes, this is a good test. If I run the pytest, it passes. And again, I have said it so many times, I should ask myself, why does it pass? So let's discuss this. What happens in this case? I go here and I check. Okay, the list is empty, so this gets returned immediately, whatever the values are here of the values of LT and UT are. And this is fine. Okay, I'm happy. I want to keep the test because it exposes a different case. You see, this checks the standard case with no thresholds. This exposes the test with both thresholds. I don't think it's reasonable to test only the presence of the lower threshold and only the test and only the presence of the upper threshold. It's probably too much. As far as I understand, this algorithm is not affected by this. But in the future, it might happen, someone comes back to you and says, oh, you know what, your average function doesn't work with an empty iterable and just a lower threshold. So in that case, you might want to create a test for it and say with lower threshold, do this and then see, oh, it works, okay, or it doesn't work because of this bug. In this case, I don't want to have this test, is a bit too much. It's a bit too much for me. And the last thing we might test here is that so I discussed iterables before, and I said, okay, what happens if I use a different iterable? Again, if you remember what we did with infinite sequences, we cannot test all iterables because the set of all iterables is infinite. You can create whatever iterable object you want in Python. So I might test tuples, I might test ranges, but that's it. So then I have to trust my code and say, okay, this works with iterables. One thing I might want to do is to check it doesn't work with non-iterables. So I might go and copy this test here and say def test average manages, well, doesn't work with non-iterable types. Doesn't work with non-iterable types. Yes. Okay. What if I pass a type which is not iterable, like not a list, but I don't know, a number? Please remember that if you pass this is iterable. It's not something you can compute the average of, because these are letters, but this is iterable. So an integer, for example, is not iterable. You cannot say for I in 123. This doesn't make sense. And we don't want a value error in this case. We want a type error, which is the standard way for Python to say, okay, you pass me a wrong type. Cool. It passes. Cool, right? No, it's not cool. We have to ask ourselves what happens. And yes, what happens is that if you try this on an integer, it fails. I guess there is a very good and easy way to do it, which is to run the test like this. Okay, so, alright, okay, this fails. Before what I said, type error, object of type int has no len. So this check here fails. We expect an iterable to have to provide a len. So passing something which is not iterable already fails here and not here. As I said before, it fails in the first line. So okay, again we understood why the test already passes, because this fails, and we want to keep it because we want to safeguard this. We want to be sure this corner case is covered by our test suite. And this is all for now, because I believe we have everything, we covered everything. Actually, no. Now that I think about it, I published this very same workshop is published in my book about clean architectures, and a reader came back to me showing me an error, and this is a very good thing because this is TDD in practice. What I mean is, I created this workshop, I presented it at many conferences, I wrote a book, I put this very same workshop you followed in the book, I published it, and after a while, after a couple of months, someone came back to me and they said, well, you know what, this code doesn't work in this case. And I was so happy about it because, and I wrote it in the book, because this exposes bug much later. So this shows everyone that TDD can give a contribution to your development. And the bug the reader spotted is the following. What happens if we have negative numbers, which I didn't test actually here, and a threshold of 0? So the test we came up with, actually the test that he sent me, is test average manages 0 value lower threshold. This works with the upper threshold as well, but this is the test he sent me. So the thing was like C equal calc. I'm really copying what he sent me. Res equal C dot average of -1 0 0 1, and the lower threshold is 0. And the assertion is that result should be equal 0.5, because if the lower threshold is 0, we should, if you check here, you should check all, you should keep, all the values that are greater or equal than the lower threshold. So what's greater or equal than 0, 0 and 1? So this gets ruled out, and 0 and 1 together average on 0.5. If we test this, what we get is a wrong result. The result is 0. Why? Because here I have this expression, if not LT, and this is true not only when LT is not none, but also when LT is not 0. And the solution is just to make it explicit. So instead of saying if not LT, I should say if LT is none. Let me check if this works. Yes, it passes the test. And I'm pretty sure we have the same issue with the upper threshold, since the algorithm is exactly the same. So I copy this test and I rename it test average manages 0 value upper threshold. So the iterable is the same. This is the upper threshold, and the result is minus 0.5. Let me check. It fails. The values are basically the same as before. This is just as minus 0.5. And the solution is the same as well. So if UT is none, get the max. Yes, it works. So as I said, I was happy when I got that message from the reader, because it was a very good way to show that TDD works. For me, it was simple to go and create a test. Well, actually, the reader provided a test. It also provided a solution for the code. But generically speaking, people might come up with a test and say, these are the input values and these are the outputs I have, and this is what I should have. So you have some material to create your test. And this is all for today's video. Just recapping what we did today, we ran through these two requirements. The class will also provide a function to compute the average of any table. This function gets two options, upper and lower thresholds, to remove outliers. We created tests and code for those requirements. We covered corner cases. So what if the iterable is empty? What if the iterable is empty and we pass thresholds? What if the iterable is not an iterable? And we have a pretty good test suite now. This is everything I wanted to tell you about unit tests. So this is the end of the project on the calculator. The workshop will go on with a discussion about mocks. Thank you.